Today we are going to look more into functions, more into the domain range, and I'm also going to introduce what a one-to-one and an onto function is. Now, this lesson tends to be difficult for students, at least in the past it was, so please pay attention here. A little bit of review first. The set of all first elements of ordered pairs, usually thought of as our x values, is the domain. The set of all second elements of ordered pairs, usually as our y values, is known as the range. The set of ordered pairs where no two ordered pairs have the same first component, so they have to have different second components. This means there is only one y that can be paired with any x is a function. We can look at a graph to determine domain and a range. If we look at the graph on the first picture on the example 1, our domain are our x values and the range are our y's. So the domain is, I can see my dots are at 1, 3, 4, and 6. So my domain is going to be 1, 3, 4, and 6. And our range, I'm going to write it below the line, are the y values. It's at 5, 2, and negative 2. I am going to write it in order. So negative 2, 2, and 5. Another example, example 2 here, you do have to imagine that parabola keeps going. The domain are your x values, so if you imagine that this parabolas keep going to the left and to the right, the domain is everything. Everything would eventually be used. The way we say everything is all real numbers. I will start abbreviating all real numbers as R with a line through it. Now the range are the y values that are used, and this time you should notice in the picture that none of the y values below this 2 are ever going to be used because this parabola is going up forever. So since the parabola is going up forever and it's never going to hit any of these, I know my range is going to be at this number 2 and higher. The way we say 2 and higher is that y for the range has to be greater than or equal to 2. It's allowed to equal to because it's on to, therefore I do have the little equal to symbol there. We will practice with this more in the future. Onto functions. A function f from a to b is called onto if for all the elements in set B, so like say looking at all these elements, there is an A in set A where that f of A is equal to B. All that means, all the elements in B are used. Sometimes these functions are, instead of called onto, they are called surjective. Now let me show you what I mean by onto. If we look at example 1 here, notice in set B, I'm asking you, are all of the B values, have an arrow next to it, are all the B values being used? The answer is yes, therefore it is onto. Same idea with the one on the right hand side. We look to see if all of our B values are used. We see that 8 and 1 are not being used, so this is not onto. Moving down to a XY axis type of graph, the B values are the range. And you look to see if the range would be all real numbers, meaning if all of the y values would be used. So if we look at this graph, we know this line is going up forever and down forever. Since it's going up and down forever, the range is all real numbers, so the function is onto. If we look at the one on the right hand side, the parabola, with the parabola this will not be onto, and I do give that away to you, and the reason is because all of these y values below -2 are going to never be used. Since these b elements, or these y values, are never going to be used, it is not onto. Now, if you notice up here, I do say something about being 1-to-1, and also down here, also being not 1-to-1. Well, let's look at to see what 1-to-1 actually is. A function f from a to b is called 1-to-1. Oops. Or 1-to-1. You can see how I will abbreviate it in the future. Whenever f of a equals f of b, then a equals b. What that means is no element of b is the image of more than one element in a. You can't have a y value go to two different x's, is what it's really talking about here. So let's look. If in a 1-to-1 function, given any y value, there's only one x that can be paired with the y. Such functions can also be referred to as injective. For example, let's look at the first one here. I have all these elements in A, all these elements in B. First, I can see it's not onto, because look at the 8 isn't being used. But in order for it to be 1-to-1, the elements that are paired in B can only have one unique element in A, and that is true. So since that is true, it is 1-to-1. Now looking at the second example, all the elements in B are used, so I could say it's onto. But if I'm looking at 1-to-1, look at element 2 in set B. Since 2 is mapped to both the H and the O, it is not 1-to-1. Now, just like we use the vertical line test to determine if a relation is a function, we can use what's called the horizontal line test to determine if a function is 1-to-1. In this test, any horizontal line can only pass through one point. So if we look at our first example in a picture, maybe I try to draw my horizontal line, and I see it only hits at one point. Maybe I pick another spot, and I see it only hits at one point. Because I'm only hitting at one point using the horizontal line test, the function is definitely 1-to-1. I can also see it is onto as well because it's going up and down forever. Looking at the absolute value problem, when I draw a horizontal line this time, I hit at two different spots. Since I hit at two different spots, I can see that it is not 1-to-1. Now it also is not onto because I am not going up and down forever on this graph. I'm bouncing off the x-axis. I'll never use these y values down here. Since I never use those y values, it is not onto. Sometimes functions can be both onto and 1-to-1. When that is the case, they are called bijective. Alright, let's look to see if these functions are 1-to-1 and onto. So first one we have here, all the elements in B are being used, so it is definitely onto. In addition, all the elements in B only have one arrow to it, so it is 1-to-1. Example on the right hand side here, all the elements in B are not being used. 8 is not being used, so it is not onto. In order for it to be 1-to-1, all the elements in B that are being used can only be used once, and they only have one arrow to it, so it is 1-to-1. And now at this point, what I would like to do is save the rest of these problems to work on tomorrow in class.